answer to summative project. So, Ms. Bailey, this is I'm going to be talking about in this presentation about the 4 different criteria, which is problem solving, concepts and procedures, um, communication reasoning, and data analysis and/or modeling. And I chose modeling in my question. So, in my first one, I'm going to be doing concepts and procedures in solving logarithmic equations. So first I'm going to talk about what the logarithmic function. A logarithmic function is when you have a y equals to a log to the base of a times x, where a is bigger than 0 and a is not equal to 1. Then a logarithmic function is the inverse of an exponential function, which is a function that it has an exponent that has a variable as an exponent. And that's basically what a logarithmic function is. So some rules, some laws of exponents that were going to be needed for this question, specifically this question, is the multiplication rule, which is a to the power x times a to the power y equals a to the power x plus y. So let's say we have 2 to the power 3 times 2 to the power 4, which equals, then you can do 2 to the power 3 plus 4, which is equal to 2 to the power 7. It's just the bases need to be the same for this rule to work. And the next rule we're going to need is called the power of a power rule. The power of a power rule is when you have a base, so 2 to the power of something, so let's say 3, and then all that in brackets and that to a power of another number, let's say 5. So then the power of power rule states that if you have that, if it's in that order, then be 2 to the power, what you do is multiply the 2 powers. So 2 to the power 3 times 5, which is 15. So 2 to the power 15 is the resultant answer. And then next, so now we talk about the properties of logarithms. And so the ones that we're going to be needing in this question is the special 1 property, which is the log base 1 equals 0, and the log base b, which equals 1. I'm sorry, log base 1 equals 0. So this one's important. This is important because it states that if you have any number after the base that is a 1, it will always equal 0. So let's say you have log base 300 and times 1, it will still equal 0. So special number 2. I'm sorry, the next property we'll be needing is the equality property, which says that if log base b of n equals log base b of n, then n equals n. So some examples, let's say, are, for example, log base 7 of 3x minus 4 equals log base 7 of 5x plus 2. So for the trick for this equality property to work out is that the bases need to be the same. So they both have log base 7 on both sides. So 3x minus 4 equals 5x plus 2. That's what it means. The next property we need to have is the power property. The power property is when you have log base b times n to the power of p. So that p is at the power can be put down and multiplied with the whole logarithmic function. So let's say, for example, log base 2 times 8 to the power of x. The x can come down and be multiplied by the logarithmic function, which equals x times log base 2 times 8. So to change the base property is also very important, which is you can just change the base to any base that you want. And so let's say you have log base b of n equals log base a of n divided by log base a of b. So let's say we have log base 3 of 4. So we want the new base to be base 10. So we do log 4 divided by log 3. Because log base 10 can be written instead of log base 10 at the bottom, at 10 at the bottom, it could just be written as log. Hi, it's Billy. So this is the concepts and procedures part of the video, and I'll be showcasing the concepts and procedures criteria in the logarithms and exponents unit through solving logarithmic equations. So this is the equation log base 8x minus log base 16x equals 0. As you can see, there are different bases in this equation. So since we're solving for x, I think the best way to do first is put log 16 of x onto both sides. Add log 16 of x base 16 of x on both sides. And this will equal out to log 8 of x equals log 16 of x. When you have this, there's a property called the change of base property. What the change of base property does is that it changes, well, the base of the property. So because these two are different, we want to make them the same base. So the change of base property, change of base. So what it is that you have log AB, you can become log CB over log base C A. So we're going to do that to both of these equations, both of these functions here. Functions. So our A is 8. On the left hand side, you can see our A is 8, and on the right hand side, our A is 16, and our B's on both sides are x. So I think the best way is to use the log base 10. So log base 10 x over log base 10 8 equals log base 10 x over log base 10 16. Now you can see a commonality between the 8 and the 16. What you can see is that they can be divided by 2, and they can and whenever you can have the exponent to 2. So what I mean by that is so for example 2 to the power of 3 is equal to 8, and also 2 to the power of 4 is equal to 16. What you can take from that is that now you can substitute this information over here, 2 to the power 3 and 2 to the power 4, for those numbers. So 2 to the power 3 is for 8 and 2 to the power 4 is for 16. On the next slide you will see. So let's rewrite that. It was log of x. Let's rewrite that with the new information we have. And log of base 10 2 to the power of 3, which equals log x divided by log base 10 2 to the power of 4. Now there's another property that can help us over here, which is called the power property. So what the power property is, so it states if you have, for example, log base b of m to the power of a, it can equal a log base b of m. So this a can move from an exponent from a power all the way to becoming multiplied with the logarithm. logarithmic function. That's what we did over here. So we can apply that property to these two logarithmic functions. When we apply that property, it turns out to become log base 10x over 3 log base 10 times 2, which equals log base 10 of x, or divided by log 4 log base 10 2. Now we can see that what we want to have is have one log on each side and not keep it so complicated. So what can we do to cancel out? What can we cancel out that's common between both parts of the equal sign, both on the left hand side and the right hand side? What is common? The only thing that's common is, other than the log of x, that can be cancelled out easily, is the log of 2. So the log of 2 can cancel out here, log of 2 cancels here on the left hand side, and same goes on the right hand side. This turns out to be log base 10 of x divided by 4 divided by 3 equals log base 10 of x divided by 4. And what you can see here is that now this it becomes much simpler from here. So anything divided by 3, for example, is like saying it's being multiplied by 1/3. So this can be rewritten as log base 1/3 times log base 10 of x equals 1/4 of log base 10 of x. Now that power property that I mentioned earlier, you can do, before I said you can do log base a b c equals c log base a b. Before we wanted the c to be, we wanted our c in one of these cases, our 3 to go to become a multiple multiplied by the log, but now we wanted the opposite to happen. So before we had it this way, but now we want it this way. So we can move the c as to become a power of the b. So become a power of the x. And we do that on both sides. So for 1/3 and 1/4. Now it becomes log x base 10x 1/3 equals log base 10x to the power 1/4. Next, what we should do is that now we should use another property called the equality property. And what the equality property states is equality. Okay. What the equality property states is that if you have the same base, so let's say log base c of a, which equals log base c of d, a, that must mean that becomes a will equal d. Now we can implement that property into this question here, this equation here. So when we do that, this becomes x to the 1/3 will equal x to the 1/4. Now this looks like simple exponents. This looks like a simple exponent question. So what we can, so let's rewrite it. X to the 1/3 equals x to the 1/4. Now there's a property called the power of a power rule, which states that so power POP, let's say that POPR, and it says a to the x to the raised to the power y means a to the x y. The reason I'm saying this is because we don't want fractions, we want to have a whole number. What we can do is we can multiply this. We can multiply 1/3 and 1/4 by a lowest common denominator. Multiply by 12. This becomes 4. This becomes 3. X to the power of 4 will equal x to the power of 3. Now we need to solve for x, so we bring this x to the power of 3. We minus it from both sides, x to the power of 3 minus by x to the power of 3, and now we can factor it. Now we can factor this. So I'll use another color. So we can do x to the power of 3. You can see that x to the power of 3 is common between both of these, and x to the power of 1 minus 1 equals 0. The reason I said x to the power of 3 times x to the power of 1 is the same. Is like the same thing. How is when is using the multiplication rule. The multiplication rule is in exponents. Multiplication rule in exponents. What this is that if I have a to the x times a to the y, that must mean a to the x plus y. That equals a to the x plus y. So if you do x to the third times x to the first, that must mean x to the third, x to the power of 3 plus 1, which is x to the power of 4, which matches here. Which matches here over here. So it checks out this factoring. Next, what we do is we solve for, we solve for x. So either x to the third equals 0 or x minus 1 equals 0. So let's do the simple one first. X plus 1 on both sides. X will equal plus 1 or slash add x cube root of 0 is x equals 0. Now let's check these answers. We need to solve for any extraneous solutions to see, or is to see if none of these solutions actually work. So if we go back to the question, which was log, we write this in the color, let's say purple, log base 8. I'm going to first plug in x is equal to x is equal to 0. Log base 8 of 0 minus log base 16 of 0 is equal to 0. When you have log base something with a 0, so as I was saying, when you have 0 when you have 0 over here, that is known as undefined. So undefined does not equal 0. So this means that x equals 0 is not a solution. X does not equal 0. So now let's check for x is equal to 1. So let's see, log base 8 of 1 minus log base 16 of 1 equals 0. when we do this, we do in fact get 0, because 8 to the power 8, because when you do this, it's basically saying 8 to the power 0, 8 to the power of 0 is equal to 1, and this also means 16 to the power 0 is equal to 1. So 1 minus 1 does equal 0. 0 equals 0, check mark. So x does equal positive 1. That is the only solution to this question. Hello, Miss Bailey. So I'm going to be doing using solving with the criteria of problem solving, and the way I'm going to do that is using the unit of system of equations, and I'm going to be solving a system of 3 equations. I'm going to be using substitution and elimination to solve this question. The only way I can use substitution and elimination is that here I'll be using substitution in the beginning, and then when I reach a certain point I have to choose between substitution and elimination, and I'll do both ways in the video. So I'll do this way and this way after starting with substitution. So let's start on with the question. So the question is solve for x, y, and z, and that's basically, so we solve for x, y, and z. I'm going to label these equations 1, 2, and 3. So I can easily see that the second equation has two variables, so that must be easy enough to isolate. I can easily isolate y, so I'm just going to do that. So second equation, I'm going to use 4x minus y equals minus 5 plus 5 on both sides, and plus y on both sides. This ends up with being y equals 4x plus 5, and now I can substitute this value of y with the y's in the first and third equation. So I'm going to do that right now. So in the first equation, it will become 2x minus 4 times 4x plus 5 plus 5z equals negative 33. In the second equation, it will become minus 2x plus 2 times 4x plus 5 minus 3z, which equals 19. Next step after this is 2x minus, is to expand it. So minus 16x plus minus 20 minus 20 and when you do minus 20, then you can do plus 5c. Let's go 2 equals negative 33. So combine like terms, 2x minus 16x, and add 20 on both sides. And add 20 on both sides. It becomes minus 14x plus 5z equals minus 13. Now let's do it for the second equation, first equation, second equation. So what will happen now is that you get minus 2x plus 8x plus 10 minus 3z, which equals 19. Combine like terms, minus 10 on both sides, minus 2x with 8x, 6x minus 3z is equal to 9. So now we have two paths to take from here. So here are the two equations, 1 and 2. Minus 14x plus 5z equals negative 13, and 6x minus 3z equals 9. We have two ways. We gotta do elimination substitution. The first thing I'm gonna do is substitution. So the best way I think I can see it is by using the simplest equation, and the simplest equation to me is the 6x minus 3z equals 9. So what I'm gonna do with that is is 6x minus 3z. So 6x minus 3z equals 9. I can either divide by 3 by everything. Divide 3 by everything. Okay. That becomes so negative 1 here. And this becomes a 2, and the 9 becomes a 3. So I'm end up with 2x minus 1 equals minus z equals 3. And now I could easily get z, so I just plus z on both sides, and minus 3, so 2x minus 3 equals z. And now I'm going to substitute this z into the z's for this equation again. 6x minus 3z equals 9 to find the value of x. So 6x minus 3 times 2 of x minus 3 equals 9. 6x minus 6x minus 9. Yeah, I just made a mistake there, I'm sorry about that. So now I've got that I used this equation already. So I'm gonna substitute into this equation over here. Minus 14x plus 5z equals 13. So I end up with minus 14 of x plus 5 times 2 of x minus 3 equals negative 13. Minus 14x plus 10x minus 15 equals minus 13. So plus 15 on both sides and combine like terms. 4x will equal minus 13 plus 15, which is 2, and I divide by 4 on both sides. This becomes half. X will equal half. So I'm going to say that this is a negative 4. So negative 4 divided by both sides. And this will end up to become x will equal negative half. So we got x is equal to negative half. So now what we could do, we can get the original equation, 4x minus y equals negative 5, and substitute this x over here. So 4 times negative half minus y equals negative 5 is 2 minus y equals negative 5, plus y on both sides and plus 5 on both sides. And what you do after that is that becomes minus 2 plus 5, which is 3, is equal to y. 3 is equal to y, so y is equal to 3. Now what you can do to solve for z is that you can substitute into an original equation, or we can substitute into that form equation we made for z, and the equation was z into 2x minus 3. 2x minus 3 equals z. So let me rewrite that here. I'm gonna put a box around it. So 2x minus 3 equals z. Let's substitute this x inside, which is negative half. So 2 times negative half, this 2 and 2 get cancelled, minus 3, and we're left with minus 1 minus 3 equals z, and this becomes minus 4 equals z. So, and now the solution is minus half, comma, 3, comma, minus 4, comma, sorry, brackets. Show me. Okay, now that I showed you the way to do it with substitution, now I'm going to show you the way to do it with elimination. So we have the minus 14x plus 5z equals negative 13, and we also have the 6x minus 3z, which is equal to 9. Now I'm going to write this by the color. So we can see the 5 and 3 can be, 5 and negative 3 can be, we can put them to a multiple of 15. So we can multiply both of these by 3, multiply the top one by 3. So as I was saying, you multiply the top by 3, and you multiply the bottom by 5. The reason you do that is so you can get this, the z term, the z coefficient, to 15. So the z's can cancel out. So this becomes 14 times 3, which is 12 and 42. So minus 42x plus 15z equals, and we just do negative 13 times 3, which is negative 39, and then you do 6 times 5, which is 30, 30x minus 15z, which is equal to, give me a minute, 45. Now when you do this, it becomes negative 12x equals 6. Now I'm just going to bring this back to over here. I'm going to bring this over there. So negative 12x equals 6. Divided by negative 12 on both sides. Okay. And this becomes x will equal negative half. The next thing we can do is that we can substitute it in the original equation that we had earlier and we manipulated earlier, which was y equals 4x plus 5 to find y. So we can do y will equal 4 times negative half plus 5, 2 and 4, and become 2. 4 times negative 2 is negative 2. So y will equal negative 2 plus 5, which will equal positive 3. So y will equal positive 3. Next step we can do is to find z. And the way you can find z is that we use the equation we had earlier, which was the 6x minus 3z equals 9. It is 6 times negative half minus 3z equals 9, and negative half times 6 is negative 3. It is equal to negative 3. So negative 3 minus 3z equals 9, plus 3 on both sides, plus 3, minus 3z equals 12, divide by negative 3 on both sides, and this becomes minus 4. So z will equal negative 4. So now the solution to this question is negative half, comma, 3, comma, negative 4. Hello, Miss Billy. So I'm going to be teaching about models and using through graphing exponential functions. I'm going to be using different models like equations, tables, and graphs. So it says to use the exponential function y equals 2 to the power of x and complete the table on the right. I completed it beforehand, and these are the results I got. So what I first did was that I plugged in this minus 2 as an x and just solved it from there using the laws of exponents. And from there, I made a coordinate. I made coordinates over here. Coordinates. And these are the coordinates I got. So to graph now, on the next page you'll see the graph of y equals 2 to the power of x, and I'll prove the points that I have here. Not all of them will be shown. So you'll see minus 2 comma 1/4, you can see it's at 1/4. Minus 1 comma half, it's proven over here. 2 to the power of 0 is 1. Here, to the power of 1 is 2, to the power of 2 is 4. So that's how I know that this table works and the function is correctly graphed. And now I'm going to be graphing y is equal to 3 to the power of x, and we're doing that in red. So to graph y is equal to 3 to the power of x, I'm going to make a table like in the investigation. X, y coordinate. So I'm gonna start from minus 1, 0, 1, and 2. So if I do 3 to the power of negative 1 becomes 1 over 3. 3 to the power of 0 is equal to 1. 3 to the power of 1, which is equal to 3. 3 to the power of 2, which equals 6. So I could put these as my y values. So 1/3, 1, positive 1, positive 3, and positive 6. So now my coordinate will be negative 1, comma 1/3, 0, comma 1, 1, comma 3, and 2, comma 6. Let's go back to the graph and plot these points. So at negative 1 we had a 1/3. So let's say this is half. So 1/3. Let's say 1/3 is around here. So we will say around there is 1.4 hour 4 hour y equals 3 to the power of x graph. 3 to the power of x graph. Now next we do is at 0. So 3 to the power of 0 is 1. And 3 to the power of 1 is 3. It's 3. 3 to the power of 2 is 6. 6 is not written on this, so I'm just going to say, so 6 is not written. So we can just draw a line, and exponential functions never touch the x coordinate. So let's say it's over there. And it needs to be a steep angle because it needs to reach 6. So around there. Let me do that again. And it keeps continuing to infinity, unless there are some zero constraints, which there are not in this question. It's gonna make it look nicer. I'm gonna take out these dashed lines. So going on for infinity. And now that's how we graph y equals 3 to the power of x. And now the next question is to graph y is equal, I'm going to do this in blue. So y is equal to the 4 to the power of x. So I'm looking at the table again. X, y column, coordinate, chord, y, x. So I'm going to do -1, 0, 1, 2, 3. So -1/4, that's at 1/4. 0, it's at 1. At 4 to the power of 1, it is at 4. 4 to the power of 2, it's at 8. 4 to the power of 3, it's, sorry, 4 to the power of 2, it is at 16. Wait, sorry. So, 4 to the, I'm going to show my work over here. 4 to the power of -1 is 1/4. 4 to the power of 0 is 1. 4 to the power of 1 is 4. 4 to the power of 2 is 4 times 4, which is 16. And 4 to the power of 3 is not necessary because it's not on the graph, but I'll do it anyway, which is 64. So this graph takes a steep curve. So 16 to 64. Now the coordinates are -1, 1/4, 0, 1, 1, 4, 2, 16, 3, 64. So let's go back to the graph and let's plot these points. So 1/3, so 1/4, it's around so we were at 1/4, and now next point is at 1, which where all of these intersect. At 4, 1, we got it at 4. We got it at 4 over here. So our graph will look something like this. And it keeps going along the x parallel to it. So in black you can see that it's y equals 2 to the power of x, in red you can see it's y equals 3 to the power of x, and in blue the graph is y equals 4 to the power of x. Now let's go to the questions. So find the domain and range for each. So domain is negative infinity, comment infinity for all of them. Oh, sorry, I messed up a comma here. Comma infinity, negative, comma infinity. Range for the y equals 2 to the power of x is that you soft bracket at 0, comma, infinity. This happens to all of them because it cannot touch 0. It is not included. Horizontal asymptote at, and the horizontal asymptote is that y is equal to 0 for all these. 0. So what effect does changing the base of the parent graph to any number greater than 1 have on the graph? So what it does is that it just makes it steeper. So it makes the graph. So it makes the graph steeper. Hello, Miss Bailey. So this is my communication and reasoning grade in the rubric, and the way I'm going to get that grade is by using the raking leaves investigation. So the problem is that you have Mr. Wiggins gives his daughter Celia 2 choices of payment for taking the leaves. One is the first method is $2 for each bag of leaves filled, or she will be paid for the number of bags of leaves she rakes as follows: 2 cents for filling 1 bag, 4 cents for filling 2 bags, 8 cents for filling 3 bags, and so on, with the amount doubling for each additional bag filled. So the way I see this, and the problem is which decision is best. So the way I see this, the first thing you should do is for the 2 methods, make an equation, which I have over here. So $2 for each bag of leaves filled. So y equals 2x. Okay. So we pay 2 cents. So for filling 1 bag, 0.02 for 1. Okay. And then 2 for 4, and 0.04 for 2, and just doubling, so times it by 2 basically. So it's times into y by 2, which is known, and this will become an exponential function. And then you gotta divide by 100 because it needs to start off with 0.02. So 2 to the power x, and then divide by 100 because it needs to start off with 0.02. That's where it started from. 0.02 cents, not dollars. Now let's go back to the question. What is the best method for her to earn money? This question, in my opinion, is not specific enough and doesn't have enough detail. But let's say, so I made a table here. The x represents bags, number of bags. Oh, I forgot to say that this equation is linear, while this equation is exponential. The way I figured out that this was linear is because it doesn't have a variable as its exponent, or it has any sort of power, any sort of thing to a power, base to a power. And I know this is exponential because it has a variable to a power. Now, x is known as number of bags, while y is known as method 1 payment in dollars, method 1 pay dollars. Okay, now we'll put this in yellow, and y1 is method 2 pay in dollars. Now, if you see this table, you can see that up to 11 bags, see the method 1 payment is gives the most amount of money, and at 12 bags, if Celia rakes 12 bags, she earns almost double of what she will earn in method 2 for 11 bags, which is $40.96. $40.96. And but now to further prove, so now I say in the beginning that this question was not specific enough and didn't have enough details. It's because of the external variables / factors that are in play. So one variable, actually no, I don't need that. One variable that is in play is number of bags that she can fill. She can fill, and how many bags will she be able to fill until she gets tired? Will she be able to fill until quitting? Until she quits. There's also of how many leaves there are, the number of leaves there are to bag, because if she has like a certain, like maybe 20 leaves, she can barely fill like one bag. But these are the external factors the question has not provided. So, and also, it didn't specify at which bag number is the best method, because overall, method 1 is better until 11 bags, but method 2 is better at 12 bags. But then again, at 8 bags, after 8 bags, method 2 is better because it gives a higher amount of dollar higher amount of dollar then the method 1, which is $2 per bag. This is basically giving around $3 per bag. And then after that, from 9 to 10 bags, it's giving a bigger profit of $5. And then from 10 to 11 bags, it's giving $10. And then from 11 to 12, it's giving $20. So it depends on how much work. It depends on the external variables of this of the question, which is not of the thing, which is not provided in the question. So, for example, number of bags, how much can she do until fatigue, and depending on number of leaves. But I have two answers to this question. One answer is, if Celia can fill up to 12 bags, I say method 2 is better. If Celia cannot fill over 11 bags, or she fills 11 bags or less, she should go for the method 1. So here's this graph to represent the bags as the x-axis and income as the y-axis. So this intersection is at 11.5, comma, it's at 11.5, comma 22. But she knows that she can't fill half a bag. So a full bag, she can't fill half a bag to get her money. So if she fills a full bag, she will get around $22. She will get around $24 for the linear equation, and she'll get around $40 for the exponential equation, or the method 2 payment. So it depends on her decision of what of Celia's effort in and the external factors that are not controllable. That are not controllable at the present time. So my two answers are: if 11 bags, if she can't fill more than 11 bags, then she should go for method 1. If she can fill 12 bags or more, she should go for method 2, payment method 2.